Hello, my name is Andrew, and I am going to talk about the I2P, what it is, how to use it, and how I2P can be used to fix problems with internet that we face. So in order to understand what needs to be fixed, let's look back into the history, how internet originated. Internet originated from US mostly military project, ARPANET, and it has a mesh design as shown here. Different interconnections between different nodes, but what lay as a basis of this architecture, it was a goal to withstand an external infrastructure damage. So, for example, if some of these nodes came down, network is still usable. And it worked very well for this thread, and it was adequate for these tasks. But no internal threads were in the middle of this network. So all hosts, all nodes, they were considered trusted. And we have this legacy with us these days. So in modern internet, we have this state of things. We have many many technologies designed to fix problems with security or with privacy, but all these technologies, they are good, but from architectural point of view, they are clutches to support, to make it somehow usable, the network we use now. So for these technologies and clutches. We are losing decentralization of internet. If in its prime times it was decentralized mesh network, now we have decentralization only on the top level of the internet. And when you connect to some ISP, then you are losing this decentralization. And you have some centralized tree networking, and at this point, for example, all traffic inspection, interception, blocking, whatever may happen. So we don't have really internet as a mesh network for common people. So what could be done to help with this, to fix this? First generation of relay networks is Tor. I will relate to Tor because ISP bases its technologies on some ideas from Tor. And Tor is well known, so it will be easier to understand this way. In Tor, you have nodes, which allows users from different real nodes to interconnect privately in some virtual space and virtual network. So that routing between these nodes is done privately, and observer will only see how traffic goes in or out. Oh, okay. It's okay now? Okay. So, what are the advantages of Tor? It is the first worldwide network. It provides hidden services in addition to anonymization, and it has a large scale, millions of users. But there are some problems as well. Tor is based on entry and exit points, and running relays may have problems with legal problems in some jurisdictions. It's not safe anywhere in our world to run these relays. Also, Tor has highly asymmetric structure. It is running about 8,000 of nodes with both bridges and relays, and this 8,000 of nodes serves 4.5 million of users. And to make it worse, Tor is based on it is highly centralized by design. It has only 8 to 10 directory servers available, and if the servers will be taken down at once, this network will experience huge problems. As we can know, thanks to Mr. Snowden, we have a global surveillance which can monitor all nodes of Tor or any network. And such world-scale monitoring poses a threat to privacy and to security. So, what is the idea of I2P? The idea is that common internet usually is beyond repair. And we need to build a new network which does not depend on the internet for anything, that for links between low-level physical links. So, I2P doesn't have the idea of entry and exit nodes. It has any participant of the network is a router by design. So what we have, no entry-exit nodes, no legal risks exposed to relays. There is a full decentralization. There are no directory servers used. Each node is considered as untrusted as much as possible because adversaries may try to inject some nodes into the network, and protocols are designed in a way to withstand this. Inside I2P, any protocol can be used, which user wants. And right now, it is approximately 50 to 60,000 of nodes available, and it is hard to get this number accurate because network is so distributed. Then special research is needed in order to get these numbers. And I2P uses unidirectional tunnels. I will talk about tunnels a bit later. So routing of I2P can be seen as a second generation of onion routing, and all you know that onion allows to connect through two hops users, and this connection is private. So how this protocol is built? A user establishes a connection with the first router with its encryption key, then with second router, with third one, and message goes through. So we have one layer of encryption in the weakest point, and all message goes through one single route. How I2P tunnels are built? They are different, and incoming and outgoing messages are going through different routes. So if you are making a ping and pong, it will go through different nodes, through different hosts. They are connected by so-called endpoints, and outcoming endpoints are hidden in order to improve privacy. Also, length of tunnels is configurable. In torrent is fixed to hops. In I2P it is usually 3, but may be set up to 7 hops if you really want to do this. That's how peer-to-peer connection looks in I2P. You have connection on application layer between A and B. It comes up to connection between each routers. These ACDE are routers, and A and B in space are endpoints. So each connection between routers is encrypted. Each connection between origin and source and destination is encrypted, and application level encryption is optionally available as well. But this is not everything. In comparison to Tor, I2P doesn't send a whole packet inside encrypted connections. It splits packets into chunks. This is called garlic routing, so we can take a garlic bulb and split it into several chunks. These chunks from different sources are combined in a new packet, and this packet is being transferred between routers, and then it is decrypted, and each chunk is sent to its final destinations. Of course, each chunk is encrypted as well here, so we have two-layer encryption, and we have traffic intermixtion. This makes surveillance very hard because you will see only that some traffic is going on, and it's very hard to analyze what this traffic is. This is a real-life example of what will happen if you have 3 hops. This is the default I2P, and 2 chunks. So, for example, we want to send ping from green circle to blue one and reply. This shows how it will go. that outcoming packet is split into pieces, goes through different hops, then it receives its final destination, and reply goes different way to the green circle. So this works for any connection, and such connections are called tuners, and they are regenerated approximately every 10 minutes. So this complexity of encryption and routing is quite hard to realize when you have many traffic from many different destinations. So how you can find some host in I2P? There is no DNS-like centralized services. It is based on DHT-like NetDB database, and this database contains two main sets of information: router info and list sets. Router info contains router information, the real IP and ports, and the list sets contains information about endpoints, and it has no direct connection to router information. It has connection to public key, which is used to identification and connection between peers. Router info contains ID. These are encryption and signing public keys, contact, and auxiliary data. All this data is signed, and all this signature is being run through hash, and this hash is being used to address the node. The network database, each node in database contains encryption key, garlic end-to-end encryption key, signing key, and all this packed into a certificate. So for management, this database is distributed. It is being run in DHT way as for using so-called fluidfill routers. Fluidfill routers are hosts which have powerful enough CPU and connections to process this data, and approximately 1/3 to 1/2 of these routers is available over the network. Not just 8 or 10 directory services in Tor, but dozens of thousands of them. And usually when peer connects, it uses connection to several hundreds of them in order to normally work in network. Each node may be fluidfill, and user may configure if they don't want to use that the host will be used as a fluidfill node. So how the addressing is done? It is done using so-called B32 addresses. And each address is SHA-255 hash of certificate, I explained previously, and it is equivalent of IP address on ClearNet. Each node may have many such addresses. They can be changed anytime, and this is example how it looks like. Well, that's not very convenient to use, but it works. So to make it more convenient, for example, i2pwiki.i2p, so-called address book exists. They just comma-separated maps between this address and this B32 address, nothing more. Users can exchange the address books from whom they trust to keep their private address books, so they do not rely constantly on some external service to receive these address books. And it's persistent storage. So how to bootstrap, how host connects to the network for the first time? It needs to know at least one IP address or at least some part of NetDB. These are usually shipped with I2P distributions or can be downloaded from various sources on the internet. Address book is also often shipped, and various subscriptions are available. Of course, you have to choose whether you trust them or not by yourself. So what cryptography is used inside I2P? For symmetric part, it's AES-256. For asymmetric, it's mostly LGML, and for hash, it's SHA. They are possible to change, but it has some problems with changing. These are signatures which are available for certificates, and that's very good that SHA-1 is obsolete now and no longer used. Most popular ones are EDE 255519 by Daniel Bernstein, and the implementation of I2PD has support for Russian encryption algorithms. This one has closed contents, it's not safe, but this one has open algorithms of how constants were delivered. So what implementations are available of I2P? There are several of them. First one is in Java. It's original implementation, but it needs a lot of RAM, and it's not good for any device. Another implementation is in C++ I2PD. It has low demands in memory and CPU usage, and it can even work on devices like Raspberry Pi. There are some forks of I2PD, but they're targeted mostly on Monero and similar integrations with other projects. So what protocols are available? You can see that at the bottom layer it uses either TCP or UDP of normal internet. Then it provides at higher level streaming and datagrams inside anonymized secure layer, which are analogs to TCP and UDP. SOCKS and HTTP proxies are provided by software, and you can use them to access the network. So how to use it? Because it doesn't have Google, yes, and you have to find somehow what to use. There are official wiki pages, messengers, social networks, torrents, and decentralized forums, some software written to transmission modified to work on I2P, and there are even distributed network file systems which are running over I2P, and you can set up your own if you're interested in it. So these are some use cases. For example, you can set up your own SSH server and connect to the server through I2P. Why it is needed? Because many people have PCs behind the NAS and they're not available, and this is much more secure than using VPN. But of course it's slow and have high latencies. This case is for using your own VPN over I2P. This is part of Tunnel's conf of I2PD, and this is a part of OpenVPN conf in OpenVPN software. So security was analyzed, and there are many threats, but right now most of them are mitigated in one way or another. The weakest part is always user. If you are using some browser which allows fingerprinting, for example, I2P will not save you from fingerprinting. You must use secure applications. Example of insecure patterns are using the same browser to access, for example, Tor, I2P, and ClearNet. There is software allowing this, but if you have same browser, then it is there are many ways to get some side channel information about you, so never do this. This includes software like Quick Proxy and Foxy Proxy. It's also not secure because side channel attacks are possible. WebRTC is security nightmare. You shouldn't use it because it allows very precise fingerprinting on your system. Of course, JavaScript, Flash plugins may also pose a threat. Secure behavior is to use a dedicated browser in dedicated environment. To use security-oriented software, for example, Tor browser can be easily reconfigured to work in I2P. And or use something very simple like e-links, which is robust. Okay, so use it, set up your own host, your own routers, be careful when using it, and have some wisdom, and contribute and develop if you can. You're welcome. Thank you.
Do we have questions? Do you want to shout out for a second? Shout it out and then he'll repeat it.
Okay, so about IQTP, it's a relatively recent project. Do you know the guys who developed IQPD? Are they trustworthy?
At least some of them are.
Okay, switch it.
Any other questions?
Testing.
Hey, how does the latency compare to using something like Tor?
Latency.
Yeah.
Well, you cannot watch video online inside ITP, but you can chat, you can download data, videos, images, some whatever you want. Latencies, it's very similar to times of dial-up networking in terms of latencies. Bandwidths are higher.
Okay.
More questions?
Hello, thanks for the talk. And I tried I2P maybe a year ago or 2 years ago, and I used a Java implementation, and it didn't consume 2 or 5 gigabytes of memory because I didn't have that much. So, like, does it consume more memory if there is more nodes, or how does it work?
It depends on how much tunnels you have. If you are a router with, for example, if you are a fluid fill router, it will consume a lot of memory.
But if I'm just a user,
Well, it depends.
Works on Raspberry Pi if you want to, even with Java.
okay, thank you.
More questions? Okay. Well,
Thank you.